First of all, welcome everybody to this morning's presentation. I'd like to introduce James Newell. James Newell is one of our service technicians at AIS, and this is the second in a series of presentations where we're educating our customers on the products we sell and you use. So this morning's presentation is proper care of pipettes and how to use them. And James, I'll hand over to you to take it from here. So welcome, James.
Thank you, Peter. Good morning, everybody. As Peter said, welcome to our second ever presentation. Today's topic is pipettes. I'll give you a quick rundown on proper maintenance and care, as well as a few tips. If you were logged in for our previous presentation on microscopes, you may expect this to go for a lengthy period of time. I assure you, this time it shouldn't. Okay, with pipettes, as you know, there'd be quite a range of pipettes that you can purchase from us, and each one from the range will have a different volume as well as precision. They can go from the very smallest model, which is for juniors. Their volume is set and the precision is relatively low, but at the same time they're very robust, and they're also very cheap. Then you can come up to the middle of the line, which is like this one, for instance. This is autoclavable, which may be quite useful. Oh, that is the wrong camera. Which may be useful to some of our customers. It depends on your needs and uses. These are higher accuracy, but the precision isn't as high as it can go. These are a bit cheaper, and you can get them in adjustable volumes, or you can get them in set amounts. This is useful for situations where you're using the same volumes all the time. You don't need that adjustability, and without that adjustability, it actually becomes cheaper and a bit more robust because you don't have the adjustment mechanisms inside. More on that later. Then you can get up to the analytical grades, and these have a much higher precision. The repeatability on these are great, especially if you're doing research. They are a fair bit more expensive, but with that, you do get the precision out of it. Another type that you will often come across will be a multi-channel pipette. Now, this, as the name suggests, has multiple channels. This one in particular has 8, and you can aspirate and dispense 8 samples at the same time. Okay. Just a couple of things on pipette care. Obviously, things to avoid while using them would be to adjust them beyond or below their range. So for this one, for instance, it's half a microliter to 10 microliters. Obviously, you don't want to go beyond that because of multiple things. One, the pipette tip itself can only handle a certain volume. Now, if you go beyond that volume, you might risk having some sample actually go into your pipette. Now, that'll cause multiple issues, and over time, it will cause your pipette to stop working correctly. Depending on the materials that you're actually pipetting, it can corrode the inside because there's a metal rod in here. It's part of the plunger. It can corrode that. It's also lined with grease on the inside, and solvents and various other chemicals will actually break that down and cause it to lose its seal. And over time, it'll leak. It won't hold your sample, and it'll become non-functional. And transversely, if you go below its capacity, you can actually unwind the mechanism inside. There are stops inside there to help prevent that, but if you go beyond them, it will throw it completely out of calibration. Something else that will throw it out of calibration too will be just dropping it. A lot of the pipettes that we service and have issues tend to be caused by dropping, and you won't know that you often won't know it's been dropped until you go to use it, and all of a sudden the volume coming out is completely off to what you're setting, or even to what is preset. And what often happens is it bends the rod inside the pipette, and you're not getting the correct volume, or it's no longer creating a vacuum inside, and it's not able to draw the correct amount of fluids or dispense it. So yeah, obviously don't drop them, very expensive. Let's go through some quick tips on pipetting. You'll want to pre-wet your tips. Now this will accomplish a couple of things. This will help reduce the sample loss through evaporation by humidifying both the airspace inside the tip and inside the chamber. Now this is useful because if you're working with a dry pipette, obviously the air will be dry inside, and depending on the material you're using, this is just window washing fluid, nice and green, nice and easy to see. Depending on the material you're using, it'll actually evaporate inside, and what you dispense out will be less than what you're expecting. So it's always good practice to aspirate and dispense some fluid at least 3 times, just to allow some of that fluid to condition the environment inside your pipette. All right, let's go to tip number 2. This is also about the environmental conditions of your pipette, but it also applies to your sample. What you'll want to do is make sure you work at a temperature equilibration. So you want both your pipette and your sample to be at roughly the same temperature, probably room temperature. Of course, that's going to differ between laboratories because you may be working in a cold environment or a hot environment. And so it's always best to try and make sure everything's equilibrated, because if you're starting with a cold solution, you can find that towards the end of your sampling period, that the volume you're actually working with becomes greater with heat. All right, tip number 3. This is a tip about tips. All right. Sometimes you will find that droplets form on the outside of your pipette tip. As you can see here, there's a droplet, and now that could actually interfere with the volume that you're trying to dispense. What can happen is it will roll off and add that little drop to the volume that you're trying to dispense. To avoid this, what you'll want to do is use a piece of paper towel to try and dab at it. You'll want to avoid actually touching the end of the tip, because it can actually wick away some of the material you're trying to dispense. All right. Oh, and obviously don't flick it, because that can often cause some of your sample to come out of the tip. All right, tip number 3, pipetting modes. Okay, so the standard pipetting mode is to expel the air first, dip it into the solution, and then aspirate. That's a standard way of sampling with a pipette. The other way is called reverse pipetting, and that's where you push the plunger down to the first stop, go beyond, because as most pipette users will know, there's 2 stops. There's a first stop, and that's to the volume that's specified, and the second stop is to help evacuate the rest of the chamber. Now, when you're reverse pipetting, what you want to do is you push the plunger down and then go slightly beyond that first stop. You don't want to go to the second stop. You want to back slightly off from that and then draw some of the fluid in. Now, the purpose of that is to preload your tip with more solution than you're planning to dispense. And then you can press the plunger back down to the first stop and dispense how much you actually need. Now, this seems really strange, but the application is for solutions that are more viscous. As you know, more viscous substances can be difficult to draw, and doing this can actually help to add a little bit more than you need, as it's going to be easier to actually dispense out than to pull in. Think of things like oobleck, so like a non-Newtonian fluid. As you know, if you try and move it too quickly, it'll actually break apart and tear. And if you do it slowly, it'll draw it in. But the problem is it's hard to draw in the correct amount, but it is easy to dispense the correct amount. All right. Yep. Tip number 5, pausing consistence. Let me put the tip back on. All right, so this is one thing some people may not know, and this really only affects samplings of 10 microliters and below. As you're working with such small amounts of fluid, you have to be more accurate. And one thing that a lot of people don't know is that the motion of aspiration, the drawing of the sample or the fluid, actually causes microscopic vibrations inside the mechanism. And those microscopic vibrations can actually cause the plunger to fluctuate slightly. So you may or may not have the correct amount of fluid inside, especially if you're working at such low volumes. What you'll want to do when you're pipetting is to move, I want to look at my thumb. You'll want to draw it up slowly and consistently, pausing at the top before you draw your pipette out. Now, like I said, this will help to equilibrate the vibrations inside, and don't drop your pipettes, and equilibrate the volume that you've drawn in. This will also help with viscous materials, like I said. Yes. So we'll move on to tip number 6. So tip number 6, pulling out. When you're sampling, you want to try and make sure that you use your pipette as vertically as possible. Tipping it isn't a good idea because the angle can cause you to either make contact with the edge of your vessel, or it will cause you to either, I'm going to just dispense this, it will either cause you to touch the edge of your vessel, which will actually cause cause the fluid inside the tip to be drawn out through wicking motion because of surface tension. So you don't want to be touching the edge of your vessel because you will lose some of your sample. And also, if you tip it beyond 180 degrees, you'll get fluid ingress inside your mechanism. And like I said before, fluid ingress isn't what you want because it can ruin your pipettes. Yes, try and keep it as vertical as possible. Moving on to tip number 7. All right, hot hands. So this is going back to the tip about environmental conditions. You want to try and keep the environment inside here as close to the environment of your sample. And what I mean by that is not only should you try and keep a temperature equilibration between your sample and your pipette, but you also want to try and make sure that you don't handle your pipette too much because your hands will heat up the inside of the vessel and it will cause the air to expand inside. Now, you probably won't notice it, but if you hold your pipette for too long, the inside will get hot, the air will expand, and it'll actually cause some of your sample to dispense. You can probably see that there's a droplet on the end of my pipette right now, and yeah, it's actually very slowly but actively pushing some of the fluid out. And that's because I've been holding the pipette for such a long time. Now, again, you shouldn't be touching your tip to the edge of your vessel, but because I'm not taking any measurements, this is okay. I'm just removing some of the fluid because I don't want to flick it everywhere around this lovely bench that Sydney University has provided me. All right, tip number 8. So this is another tip on tips. All right, so just the tip. What you want to do when you're sampling is make sure that you're only putting your tip into your fluid or into your sample. Now, what you want to aim for, now this doesn't help, what you want to aim for is just the first up to, let's say, 5 millimeters of your tip in the solution. Obviously, if you go beyond the tip's length, you'll start to get some fluid ingress through capillary action into the sleeve of your pipette. Fluid ingress can cause so many issues, such as corrosion. It can break down the grease that's inside here. And also, when you're not looking, some of it can come back down and cause you to dispense a higher volume than you intend. This will also reduce the formation of, or the likelihood of the formation of droplets on the outside of your tip as well. All right, and this will be the final tip on tips. Make sure you choose the right tip. As a general rule, it's best to go with OEM parts. So OEM being original equipment manufacturer. So try and go with the brand tips. So Acumax, try and go with Acumax tips. Of course, aftermarket is good, but the trouble with going aftermarket is you can't be absolutely sure they're going to fit your pipette perfectly. Of course, there's going to be a bit of trial and error, and some aftermarket pipette tips are actually much better than the original OEM. Okay. On top of that, you can actually get multiple types of pipette tips. Obviously, aside from the volume range, you can also get ones that are made from different polymers. And the reason for this is that it'll actually help in the dispensation of your sampling. Some of them are hydrophobic. Don't quote me on this, I'm not absolutely sure yet, but some of them are either coated or created with a different material that causes fluid to run off of it much more readily, or it could be electrostatically treated. I need to double check that one. And that'll help to reduce the formation of droplets on the outside as well as the inside. That's one thing I didn't cover. Droplets on the inside, that can form when you aspirate too quickly. So if you dip your tip in and then just release the plunger. Try avoiding doing that because the speed that the fluid comes in will actually cause it to splash up inside. Some of it will go inside and some of it will stick to the walls. And when you're dispensing afterwards, you won't be able to remove some of the fluids that are stuck to the inside wall of your pipette, causing you to dispense a smaller volume. All right, so I'll just quickly run you through how to service your pipette. All right.
James, just while you're getting set up there, I'd invite our viewers, if they have any questions or comments, to please ask them or put them in the chat, and we'll address those as we go along.
Oh, yes, of course. All right. When you purchase your pipettes, they will come with some basic tools and service parts. Of course, you'll get some sample tips. There's a nice label there. You'll also get some grease, and you'll often get the tools required to service your own pipettes. I'll give you a quick rundown on how to dismantle your pipette and how to grease it. All right, I'm going to put this one aside. So for the AccuMax pipettes, this is not necessarily the same for all pipettes, but for the AccuMax pipettes, it comes with a little wrench, and I'll show you how to use that now. First of all, you'll want to remove the tip. That totally didn't just go off the table. And then you want to remove the outer sleeve. All right, and the way to do that is to depress the tip ejection, and then take the pointed side of your wrench and slip it into this groove just here. All right. One thing to note is that everything here is spring loaded, so you'll want to hold on to everything. So you'll want to hold on to the plunger as well as the tip ejection sleeve. So slip it in. That unlocks a clip, and then this was going so well before. All right, slip it in, and you can release the plunger. Crying out loud. All that practice. All right, you want to pull the sleeve away, put that down, and then holding on to this, you want to remove that. There's a spring inside. Yes, please be careful because these will go flying across the room. Okay, next thing you want to do is remove the shaft inside. Again, this is spring loaded, so just loosen it, take hold of it, and remove. All right, there you go. All of this will be covered in grease. So when you service these, let's get a grease bottle. You'll want to take the small amount of silicone grease that you're provided with and smear it all along the entire shaft. You'll want to get it inside the plunger, along the springs, along these springs, and well, basically the entirety of this shaft. Now the reason for that is because this whole unit is sealed on the inside, and the grease helps with that. Inadequate greasing will cause the vacuum that's inside the pipette to fail, and you will not be able to draw the correct amount of fluid whenever you're aspirating your samples. All right, and the way to put it back is to literally just do everything in reverse. Now, I will do that later because this is a little bit difficult to line up, especially on camera. But another part of the pipette will be the upper plunger mechanism. I would not recommend dismantling this due to the fact that this point up here on the AccuMax pipettes, some other models of pipettes also have this. I would not recommend dismantling this because the second that you adjust this, you actually throw it out of calibration. Now keep in mind, this is also spring loaded and you don't want to lose that. This spring is quite large, so this definitely will shoot across the room. Any adjustment at this back end here will throw your pipette out of calibration. Let's go back to the front camera. And if it's been taken out of calibration, then you'll need to recalibrate again, and that'll involve using a balance that has at least 4 to 5 decimal places and a great deal of time. So I don't recommend dismantling it to that extent. Now, of course, if you have any troubles with them, you can send it our way and we can calibrate it for you, do any repairs for you. Those are all services that we provide. We also sell pipettes. So if you're after anything, feel free to send an inquiry and we can send a catalog your way. If anybody has any questions, feel free to ask them now.
You've done a great job in covering those tips. Thank you, James. And also the servicing aspect. Obviously, you create a few spare parts there all of a sudden, don't you?
They're not spare parts. They'll go back together.
Yes, yeah. Indeed. So do we have any comments or questions from our viewers?
Yes, please. I have a question.
Yes, Shirley.
Yep.
So how would you clean the inside of the pipette if, let's say, it's contaminated or got a unwanted solution inside? So what would you use and how would you proceed with that?
Well, it's going to depend on the material that you're trying to pipette before. You could run water through it or a solvent of some sort to dissolve whatever had gotten into your pipette. Some of them actually have filters as well, which help to reduce the sampling risk. And you could always just swap out the filter and double check inside the barrel that nothing's in there. Do an inspection, of course. If you don't need to clean it, don't clean it. But if you do, run some solvent through there. Obviously, depending on the material you've been dispensing, because solvents don't interact well with certain chemicals. And then allow it to dry. Just leave it to dry for a whole day, overnight. If it's autoclavable, put it in the oven at a low temperature. And then re-grease everything. And then you can put it back together, but then double check that it hasn't been thrown out of calibration as well. And to do that, you just take a sample of water. Of course, it has to be at the same environmental temperature as both your balance and the environment, and check the weight of it.
Right. Okay.
Does that help?
All right. Thank you.
Thanks for that, Shirley.
All right. Thank you.
Okay, I see there's a question from SP. Hi, what is the best way to aspirate or dispense foamy liquid such as SDS or any detergent? Okay, so this is the detergent. I should have watered it down, but to help prevent the bubbles, but I did actually want the bubbles for a certain part of the presentation. That part being the part about droplets on the outside of the pipettes. That's why I purposely used this, because I knew if I switched it around, it would cause a bubble to form on the end, and I could pretend that was a droplet. All right, with these, simply make sure that you, if you're trying to dispense these, now this isn't too bad, but I'm assuming that you're working with agents that are very, very foamy. Of course, before you start, you want to make sure that it's settled, that you're not sampling the foam itself, because obviously you don't want the foam, you want the fluid. What you'll want to do is you'll want to push all the air out first to the first stop, dip the tip in, and draw the fluid in as slowly as you can. And then obviously pausing. And then you'll want to draw it out as gently as you can before you dispense. Now, of course, you could just shoot it directly into the receptacle, or you could try and dispense against the edge and use that surface tension to prevent the fluid from interacting with the air so much. You don't want to agitate it too much. That's one way to do it. I can't think of any other ways you could do that to help, but generally just do it slowly, do it carefully, and be mindful of what you're doing. And that should help with the dispensation of foaming materials. Does that answer your question? Fantastic.
Excellent. Thank you for that question, SP, and thank you, James.
All right, any more?
Okay.
Yes, it is a bit of a different system. I am not too familiar with the other products, but they all generally work the same way. Sorry, for some context, I've just read Christopher Wilson's comment. Yes, there's lots of different types of pipettes. Unfortunately, I wasn't able to bring with me one of each type that we sell and / I know of because of weight restrictions, and my luggage was quite full from taking microscope parts with me. But yes, there are a large range of pipettes. Some of them don't even need a tool to remove the sleeve. You can actually just twist and pull. And some of them are very bare bones. It looks almost skeletal. Those are really good for students because you don't want the extra moving parts. You just want to make it as simple as possible. And we sell those because they're quite robust.
Excellent. Okay, James. Well, I think we'll wrap it up there. Thank you so much to our viewers for being there online, and I hope you've got something out of this morning's presentation. And thanks, James, for making it all possible. And thank you to Sydney University for the use of their room.
Yes, thank you, Sydney University.
Okay, we'll have future presentations coming up, so stay tuned for more information about those.